We're go to math.com, click that calculus button. Let's go down here to concavity, and I believe we're going to be finding inflection points again, I guess. Didn't we already do that? Don't know. Alright. Find all inflection points. Find all points of inflection, however you want to say it. We got h of x equal to 3 roots of x minus 2 plus 4. So we got the graph here of h of x, and you can see this red dot indicating this is where the inflection point is taking place. Okay, 1, 2, 1, 2, 3, 4 is what it kind of looks like right there. Did I 1, 2, 2, 4, 2, 4, 2, 4? Is that just a coincidence or what? Anyway, okay, let's write that down. Let's get over to the whiteboard. Alright, so we have h is equal to 3 roots of x minus 2 plus 4. And I'm going to go ahead and write that in exponential form. We'll skip that step. Okay, so we have, I guess we're going to be working in some blue now. H of x is equal to, like I said, I'm just going to go ahead and rewrite that. So we can take the derivative and plus 4. Alright. So we got h prime of x is equal to 1/3 x minus 2. Subtract 1, you get negative 2/3. And the derivative of the inside is just 1, so I need to write that. And derivative of 4 is 0. Alright. And what are we doing now? Forgot what we're doing. We're taking the derivative again, I guess. So take that negative 2/3, bring it out front. We're going to end up with negative 2/9 x minus 2, subtracting 1. Now that's negative 1.5. Let's think of it that way. And then if you guys, so it would be negative 2.5, negative 5/3. Is that right? Don't make me have to do some arithmetic over here. Minus 3 over 3, because that's just 1, negative 5/3. We're going to have to review on our fractions there, Chief. Okay, I'm going to go ahead and rewrite this. We have negative 2 up in the numerator, 9, and x minus 2 to the 5/3. Yeah, you might want to review over your fractions. I need to line my stuff up a little better. Sorry about that. Okay, where are we at? Okay, so we want to set this thing equal to 0. I've been kind of skipping that step, but I probably shouldn't skip any steps, you know, unless I'm going down the stairs. Alright, well, the only thing we can see here is if we plug 2 in the denominator, we get 0. Alright, and so let's do that. We're going to use 2. Okay, now we can pick a number to the left of 2. Let's pick 0 for a test point, since 0 is in the domain of h of x. So we take 0 and we want to go h double prime of 0. H double prime of 0. So we plug 0 in down here in the denominator. Okay. Now remember, we have a negative out here. Right. So we end up with negative 2 raised to the 5/3. Well, that's just going to give us a negative number. And a negative over a negative is positive. So this ends up being a positive number. And we don't care what the number is other than its sign. So it's positive. So we know that this is going to be concave up to 2. Now let's choose another test point like 3. Right? Plug 3 in, we end up getting a positive number down here, but we have a negative out here. So h double prime of 3 is going to be a negative number. Okay? So that's negative, so we know that's going to be concave downward. So there you go. Do you see this? Where can I write this? I don't know. Where can I write this? Write this down here somewhere. Alright, so we have concave up from negative infinity to 2, and concave down from 2 to infinity. Now let's go back and take a look at this graph. Alright, as you can see here, concave up, so we can tell a lot just by looking at the picture, right? And then concave down. Remember, think of concave up as holding water, even though the water would roll off. But this has no chance of holding any kind of water, right? And of course, there's our inflection point, and I just now realized that that's really what we're after. I guess I didn't read the instructions, but we got the concavity out of the way, didn't we? So all we had to do was take 2. Well, no, actually we did need to find the concavity, because an inflection point occurs only when there's a change in concavity. A change means that this has got to be concave up and this has got to be concave down, or this has to be concave down, concave up. But there is actually one other thing. 2 must be in the domain of h of x. In other words, we must be able to put a tangent line at that point of inflection, even though the tangent line might be vertical. Okay, well, that's not a vertical line, is it? Wow, that's even getting worse. Forget it. Okay, so the inflection point, remember the inflection point is 2 comma, and then we take that 2 and plug it back into the original, which is h of 2. And of course, if you plug 2 in, you get 0 here, and you're left with 4. So h of 2 would actually be 4. So we do have to determine the concavity of the graph in order to determine the inflection point. Alright, let's go back. Let's click the answer because we want to make sure that that's all correct. Inflection point is 2, 4. There you go. Alright, so where are we? We're gotomath.com, and you can come practice that if you wish. Alright, see you there.